Hello students, today we are going to discuss about doubly linked list. What are the insertion and deletion operations? We'll try to learn in a very simple manner. So these are the insertion and deletion operations. So here doubly linked list, it is another form of single linked list where navigation is possible in both forward and backward. If we talk about single linked list, we always go to the next link only. We can't move to the previous link. But here in double linked list, we can both make forward and backward traversal. And these are the components of students which we have. Each link of a linked list can store data called an element. And then we have each link of a linked list contains a link to the next link. And we can also traverse back from a node to the previous link, and which is called as previous. And then we have a connection between different linked lists using this link. So let us understand this in a more easier way. So let us take an example of a train. Let us consider that these are the different nodes which we have. So this is a node 1, node 2 and node 3, and this particular um, compartment we can take it as a one node, and here we have two windows, that is previous and next. If it has some node before this, some compartment before this, you will have that compartment name here, otherwise you will simply give here as null. So here for this compartment we don't have any compartment before this, we have directly engine, right? So here we will keep it as null. In this window we have null, and in this window we have next. And assume that this compartment will allow only single passenger at a time. It has a capacity to hold only single passenger. So here we will take it as data as one hour single passenger in each compartment. So what can be the compartment names? It can be S1, S2 or A1, A2 and so on. So here we will take it as S1. S1 is a compartment name of this one, and S2 is a compartment name of this, and S3 is compartment name of this. So let us understand the concept with a diagram and as well as a code parallelly. Okay. So here if you see, we are creating a structure for the double linked list. Since this compartment stores different types of data, like in between we have integer data, previous segment of this compartment will store the address of previous compartment, and next is the it is also storing address only of the next. So previous and next are actually holding the address. So this we will declare it as a pointer, because in C we use pointers to store the addresses. And data is where we give normal integer numbers, okay, positive numbers, negative numbers. So it is normal integer data type. So here we will declare it as int data. And since we can't use these arrays for this compartment, because all three are of different data types, we have to go for structure concept. So here we are creating a struct code, and the name of this compartment is node. So here I'm giving the name of the structure as node. Within this I'm creating these three segments within a single compartment. So here node star previous. So previous is a pointer which belongs to this particular node. So the data type of this previous is node. And similarly data is storing integer numbers. Data type of this is int. So I'm declaring it as int data. And next is also storing the address. So it is declared it as star next. And data type of this is node, because it is actually storing the address of a node. It is not storing address of any variable, right? If it is a variable, I will declare it as int star next or float star next. But here it is simply storing address of node. So here we will declare it as node star next and close this. And for every compartment, when you join all the compartments of the train, it will be moved only when we have the engine, right? So here we definitely require one engine which is storing the address of only the first compartment. Okay, so in a real-time scenario, where is the engine allotted? An engine will be always connected to the first compartment. So here we create an engine with the name head, because now at presently we are just creating, we are not attaching this engine to the first compartment. So here simply we have created, and it is not connected to the first compartment, so that's why it is equal to 0, right? It is nowhere connected to any compartment. So just a structure is created. Now memory is not allocated for this. Now this code is only for creating the structure. Now let us connect these two. Now this is a function to create a new node. Now how to create a memory to this, how to store it in database. For that we need to use malloc function where immediately memory will be allocated to this. So here I am giving new node of data. So since data previous and next, these are all structure data types, we can use arrow operator because a new node itself is taking one address. So here we are because we are storing actually address, we can create this new node itself as a pointer. So I'm writing it as star new node. Star implies the address of this compartment. Okay, so within this compartment I have to create 3 segments, so that's why I'm writing new node of data equal to 5, new node of previous equal to null, and new node of next is also null. Previous equal to null because before this compartment there is no other compartment attached to this. Similarly next also there is no compartment attached to this.